This screencast is going to look at how to enter data into SPSS and prepare the data for analysis. Imagine that we have asked participants to fill in a questionnaire about their social physique anxiety. There are some demographic questions, such as their gender, age, and how many fitness classes they choose to teach per week. And then there is the main questionnaire, measuring their social physique anxiety. There are 12 items which are measured on a 1 to 5 scale, with 1 being not true at all and 5 being extremely true. It's very important when we enter data into SPSS that we ensure that each questionnaire item is entered on a separate column. We also need to make sure that all the data for the same individual for each participant is entered on one row. As you can see in the current spreadsheet, we have data from all the individual participants on different rows, and the columns are labelled by the variables from the questionnaire, the items that were used on the questionnaire. By going to Variable View, we can see the different items used in the SPSS spreadsheet. So we can see that there are variables for sex, age, and classes, and also for the 12 social physique anxiety questionnaire items, with the labels showing exactly what each item asked. The first thing we need to do to prepare our questionnaire data is check that there have been no inaccuracies when entering the data. To do this, we go to Analyze, go to Descriptives, and select Frequencies. And in this example, we want to select all the social physique anxiety items and move them to the Variables box. Then we click OK to run the frequencies. By scrolling down, we can see the frequency of responses for each individual social physique anxiety item measured. For the first item, we can see that all the responses are on the acceptable range of 1 to 5 that the scale was measured on. The same is true for the second item. However, we can see in the frequencies box for the third item that there are two values of 11 and 55 which have been recorded. We know that this is not possible as the scale used on the questionnaire was 1 to 5. Therefore, we know we have made an error when entering the data into SPSS. And again, when we look at the frequencies box for the fourth item, we can see that there is a value of 33, which again we know must be incorrect as the scale used was a 1 to 5 scale. Scrolling down, we can see that all the other frequencies for the items used in the questionnaire have acceptable ranges. That is, there are no more mistakes from entering the data. We have now identified that data from 3 participants has been incorrectly entered. Now we need to decide what we are going to do. If we had access to the questionnaires in a real data collection situation, the best thing to do would be to go back and check the items for each participant where we know the data is incorrect and re-enter the correct value. However, in this case, we are just going to replace the mistaken items with our missing item number, which is 999, as explained in previous screencasts. To do this, we go to use the Edit menu. First, we highlight SPA3 in the spreadsheet, as we know that this is one of the variables which has the mistaken items. Next, we go to the Edit menu and select Find. From our frequencies output, we know that one of the mistaken items was the number 55, so we type this into the find box. We are also going to tick the replace box so that we can replace our incorrect data with 999. After ticking the replace box, we type 999 into the replace with area. We then click Find Next. As you can see on the spreadsheet, the value of 55 has been highlighted. By clicking Replace, we can replace this with 999. The warning box simply tells us that there are no other items within the SPSS 3 variable which are 55. We click OK, and then we can check for the other incorrectly entered items. To check for these items, we now put 11 in the find box. And then click Find Next. Again, we can see that the value of 11 has been highlighted in the spreadsheet. By clicking Replace, it will remove the 11 and in its place will be 99. Again, the warning box shows us that there are no more items of 11 for SPA 3. Next, highlight SPA 4 and again go to Edit and then Find to remove the incorrect item in this variable. For SPA 4, the incorrect item was the number 33, so we type this into the Find box. And we again tick the Replace box to replace the 33 with our missing item number 999. We click Find Next to find the item in the spreadsheet, and then click Replace to remove the 33 from SPA 4. Now we can click Close and proceed with preparing our questionnaire data. Now we have removed the incorrect items from the spreadsheet, we now want to create an average score for the social, physique, anxiety questions. However, before we do this, we need to check that all the items are measured in the same way. By going to Variable View, we can see that some items are worded positively and some items are worded negatively. For example, for the item I am comfortable with the appearance of my figure, a high score on this item would indicate low anxiety, whereas a high score on the item I wish I wasn't so uptight about my figure would indicate high anxiety. So before we create an average for social, physique, anxiety, we need to reverse, or what is called recode in SPSS, the items which are positively phrased. In other words, the items where high scores indicate high anxiety. To do this, we go to the Transform menu, and then we have a choice of two options. We can select Recode into the same variables, which will keep the variables as they are under the same names, but will change the values. We could also do Recode into different variables, where new variables will be created with the reversed items. Generally, it is better to recode into different variables, as we want to keep the original items in the dataset. So, in this example, I am going to choose Recode into different variables. Next, we need to identify which variables we wish to recode and move them into the input variable and output variable box. In this example, there are 4 items which are positively phrased. They are SPA1, SPA5, SPA8 and SPA11. So I'm going to select these variables and move them across to the box. Next, I need to select SPA1 and decide what I am going to call the new recoded variable. To keep things simple, I am going to use the name of the original variable, for example SPA1, followed by an R to indicate that these items have been reversed. So, under output variable in the name box, I am going to type SPA1R, and I'm also going to label it so that I know what this variable is. I'm then going to do the same for the other 3 variables which need to be recoded. Next, I select old and new values to reverse the scores. Now I need to tell SPSS what the original values are and what I want them to be replaced with. So, in the box for old value, I'm going to type 1, and I want to change this to be the opposite end of the scale. So under the box for new value, I'm going to type 5. I then click Add. We then need to repeat this step for all the items in the scale, so 2 will become 4. And even though our midpoint of the scale, 3, will stay the same, we still need to specify this within SPSS. So in this example, both the old and new values are 3. If we fail to do this, the value of 3 will not appear in the recoded variable. Therefore, we would lose the data of any participant who had responded with 3. 4 will become 2. And finally, if someone has answered 5 for these items, it will be changed to 1. Click Continue, and then OK to create the new variables. By scrolling across, we can see that these variables have been added as new columns within the spreadsheet. Now that we have recoded our variables so that they are all measured in the same way, we can now create an average for social physique anxiety. To do this, we go to Transform and select Compute Variable. First, I need to give the new variable a name. For this example, I'm going to call it SPA average. However, I need to remember that you can't use spaces in SPSS. So I'm going to separate SPA and average with an underscore, and type this in the target variable box. Next, I'm going to type mean followed by an open bracket in the numeric expression box. I now need to select the variables which I want to use to create my mean for the average of social physique anxiety. To do this, I select the individual items and move them into the numeric expression box. There are 2 things I need to remember. First, I need to make sure that I take the recoded variables, for example SPA1R, rather than the original items, so that I've got the items which we've reversed the scores of. Secondly, I need to remember to separate each item with a comma. Once you've entered all the items, finish with a closed bracket and then click OK. When we scroll across, we can see that an average social physique anxiety score has been created for each participant at the end of the spreadsheet. The final thing that we're going to look at in this screencast is how to check the internal reliability of our items. Put simply, this is to check that all the items are related to each other so that we can be certain that they are all measuring social physique anxiety. To do this, we go to Analyze, select Scale, and then choose Reliability Analysis. Now I need to select all the social physique anxiety items and move them into the items box, making sure that I select the recoded items, which I've reversed, rather than the original items. Now I've selected all the items and I'm going to give the scale a label. In this example I'm going to call it SPA Reliability. I'm then going to select the statistics box. In here I'm going to select the Scale If Item Deleted box. This will tell me if there is a particular item which doesn't fit with the others and how the reliability of the scale might be improved by removing that item. Then I'm going to press Continue and then OK to run the analysis. The main interest in the output is the reliability statistics box, which gives us Cronbach's alpha coefficient. In this example, the alpha coefficient is 0.933. Generally, if this value is above 0.7, this is an indication of adequate internal reliability. So in this case we can see that the scale is much higher than 0.7, so we can be satisfied that all of the items are suitably related to each other. Having scrolled down, we can see how Cronbach's alpha might be changed should we delete items which don't fit particularly well with the other items. However, in this example, there are no items where Cronbach's alpha would improve dramatically if we removed that item. Therefore, we can be confident that we should be using all 12 items in further analyses. That concludes the screencast on preparing questionnaire data. We have looked at how to identify inaccuracies in data entry, how to recode variables, how to create means, and also how to check the internal reliability of our items.